Hello and welcome on the channel. So today we are going to start a new series about how to do a save system. Well, you might already know some solutions that are in Unity, like using the player pref, which is good for small save systems but can really become quite tedious, or using a file at the JSON format, which if you start badly can really fast become a nightmare. You might also know how to use a database, and there are two databases that are really useful on Unity. That would be the SQLite database and the RealDB database if you don't like SQL. What you might wonder about when doing a save system is how to handle the data corruption of your save files, how to store your data on the cloud so your players can access them on multiple devices, and how to scale your data save system, because at some point you want to add some new functionalities and save them. Today we are going to focus on two things, the entity concept and a naive approach on how to save file using Newtonsoft. We are going to talk also a bit about data corruption. So let's get to it. So the save system is quite simple. You've got a save manager, save services. The save manager is here to manage how the save system is going to work, and the save service is going to work with the I/O on the system, everything about saving and loading files. We're also going to have a save system presenter, which is here to do the decoupling between the save manager and our UI. For our UI, we've got just a simple test script with the possibility to save, to load, and to add to a simple counter. Okay, everything starts with the entity. An entity is an object which is here to map some data you saved either in a database or in other kind of files. So our entity is quite simple. We've got stamp for the actual version. You could add a timestamp below that if you wish. The goal is to know in which version of your save system you are, and if it changes, to let you handle the changes, to make sure your player doesn't lose any data. The score is what we are going to save, but you can save more things, like a position, like a transform and everything. Don't just remember that if you're saving JSON like we are going to do in this video, you cannot directly save a transform. You have to create a transform entity or a vector entity where you'll have a set of floats that can be saved. Like it's serializable and it's going to work. Okay, we've implemented the interfaces for iClonable and iEquatable, which are some interfaces from C# here to make it possible to just clone your entity, or just compare different entities to know if they are different or not. We're not going to use the equal in this video because it's more to compare the two different files, and we're not going to use the clone that much, just a little. This save system comes with a way for you to define a default user entity. So it's a scriptable object in which you have user entity that you can set in the inspector, and then when you want to get your default user, you just use the get user method, and it's going to do a clone of your default entity, the default user entity. Why we are cloning? Because we don't want to modify our default user while in game, so we can retest, test again, and not test only one time. Because scriptable objects should not be used to save data. They are used to be data tables. It's a bit different in some way. To do our I/O, as I told you, we are using a script named save services, and it's static, so we're not instantiating anything in it. Don't mind the hash key and everything for now. It's for something in another video about how to hash our save file to make sure of their integrity and make sure we have not broken something while saving or loading. We'll make something with some backup files so you don't lose data. So stay tuned for this one. Here we are going to starting pretty simple with a template method to load. You give you send the file name as a parameter. Don't mind the hash. For now, we are going just to send an empty hash and set it as empty. Then, using the method getFilePath, which is just a concatenation of the application persistent path, which is your app local data followed by the name of the organization, followed by the name of your project, and we concatenating the file name .json for your file name. So it makes a path. We are looking if there is a file with a stream reader. If we don't get any, you'll get an exception, which is caught, and you'll get a debug log into your console log. If it finds something, it's not going to throw, so you'll be able to return the actual file you got, or the data, the object mapped on your entity. Okay. To save, we are just going to call the save method, sending it our entity and the file name we want to save, entity2. Don't mind the bytes. You can use void for now, cause it's for the hashing as well. So quite simple again. We are creating a path with the same method and when we're getting the path to load, and then we use a JSON string. We're making a JSON string from our data, and then we're writing all the text in the file we just created. And don't mind the bytes, again, it's for the hashing. I added a little debug.log right there, so you know where you saved your stuff. It's important to use try-catch to catch errors and to, well, maybe you want to handle I/O exceptions differently than you're handling other exceptions with rollbacks or stuff like that. Right here, it's the most simplest implementation of your error handling. It's doing quite nothing, it's just debugging on your console. Okay. And that's it for our save service. Our save service is used, if you're going in references, by our little save manager. The save manager has a version built in, so you're changing the version in the save manager when you're changing your database, or at least your save file, or the way you're saving your stuff right now. And there's a rule to know if you reset the data of the player when you change the version. Now I use it in my project because it's quite useful, because each time I'm adding a feature I'm changing the version, so I can always use my default user. Okay, in terms of data, we've got the user entity, which is going to be set once you load on awake, and we've got the user scriptable object that we saw a bit earlier, where you can get the player to get the standard default user entity. Okay, great. Those bytes, again, don't mind them, they're for the hashing, and we'll add this feature in another video. We've got a linker presenter, if you prefer, to, as I told you, to link to respect the MVP pattern we discussed in the previous video, to link our save manager to our UI. There are two events which are there to request the change of score or to request to save the data. On awake, we load. We try to load our data. Maybe it's not going to work because there is no data. So if our entity is null, we are just going to get the default user. If our version changed, and if we want to reset version change, we are going to get our default user. Anyway, we are going to tell the save presenter that we've got a user entity. But that's quite simple. When you want to save, you just set the version and you just say, okay, I'm saving to a JSON file. When you want to change the score, you're setting the value this way. Your save presenter as a reference to the user entity. So maybe you would think, yeah, let's go, let's change our data from any gameplay mechanics. But that's not really safe in a way that you want your saving to be centralized. So you make sure once you're going to include in your games some threading or stuff like that, you make sure that it's handled properly and you will not have some concurrency or stuff that's going to break your game. So to make sure you cannot modify this, there is a little internal void in front of the set score. This internal keyword means that this method is public only for the other scripts that are in the same assembly as this one. So you're going to make an assembly for your save system and other assemblies for your other gameplay mechanics. Okay. This is a presenter. I'll give you some time to just copy that. The main idea is you have a method, you have an action, and as you can see, there's no dependencies, or at least there's a little dependencies on the script. There's no reference to the save manager, and there's no reference to the gameplay mechanic that's using to use this script. Which means you make your presenter, and if you want, you can make some custom methods using the context menu and making the method below that. So in this way you can test your code, test your UI without your backend, or test your backend without your UI. It speeds up your development process and make sure you're making less mistakes. Okay, I guess we're pretty much done about the overview of this system. Right there, this is my presenter. As you can see, there's nothing. There's only events in this one, and there is my start user save data, which is the user entity as a wrapper, and that's what I'm saving. My default user has a score of 120. Okay. To test this, I made this script, which is the test save system script. Pretty creative, you know. You have the presenter, which is referenced there, where you're going to be able to call presenter save a request to save data, where you're going to be able to call, okay, I want to increase the score, or where you're going to be able to find your entity and in its current state. In terms of dependencies, we have only one to show the score, the actual score. And in terms of data, we are just storing the actual score, which is not... You don't have to do this, but you can do this another way, but it's quite simpler for the demonstration purposes. Each time I'm changing something, I'm updating the UI with the update UI. It's pretty standard, and it would work. Mind the namespaces. It's quite important to put namespaces on your code to make sure everything is self-contained in its own namespace. We are going to have many services in our save system. We are going to have many entities in our save system, and we don't want them to have references to something else that's not related to what they are doing. Okay. So that's a great moment of truth. We're launching the game. Okay, we want to load. Well, I already used the system, so it's 8. I'm going to decrease that, save. I'm closing the game, starting the game again. I load, I get 2. In terms of where it's located, press save to get the path, and entity.json. And I've got my JSON file. Your JSON file is going to be much bigger, and at some point we're going to want to just subdivide it in multiple different files. So that's going to be it for today. Thanks a lot for watching. Please subscribe, hit the bell, and leave a like if you wish. See you in the next one.